My name is Jessica Watts, and today we're going to be discussing the Wilcoxon Signed-Rank Test as part of our final group project for Dr. Glover's elementary statistics class for the spring 2014. The Wilcoxon Signed-Rank Test is named for Frank Wilcoxon, who in a single paper proposed both it and the rank sum test for two independent samples. The test was popularized by Sidney Siegel, who made it popular in his influential textbook on nonparametric statistics. Siegel used the symbol T, similar to the symbol W, for a value related to it, although it was not the same as W. Because of that, the test is sometimes referred to as the Wilcoxon t-test, and the test statistic is reported as a value of T. Some qualities of the Wilcoxon Signed-Rank Test. It's a non-parametric statistical hypothesis test, as they all are in this video. It's used when comparing two related samples, matched samples, or repeated measurements on a single sample to assess whether their population mean ranks differ. It's used when the samples are dependent, that's very important, and it can be used in place of the t-test for dependent samples, although it does not require the condition of normality. 3 assumptions to consider when working with the Wilcoxon Signed-Rank Test. Number 1, data are paired and come from the same population. Number 2, each pair is chosen randomly and independently. And number 3, the data are measured at least on an ordinal scale, although they do not have to be normal. So here's the example that we're going to work through to illustrate the Wilcoxon Signed-Rank Test. In my 11th grade English class, I wish to see if the writing assessment practice scores vary depending on the time of day students take the test. A sample of 6 students took the test in the morning, and that same sample of 6 students took the test on a different day in the afternoon. So here's all of our data put together in a table labeled writing assessment scores. So on the far left column, you can see all of the 6 students. And in the middle, you can see those students' morning scores. And on the far right column, you can see those students' afternoon scores. So how are we going to work through the Wilcoxon Signed-Rank Test? The first thing we're going to do is state the hypothesis and identify the claim. So our hypothesis 0, or the null hypothesis, is that there is no difference in the writing assessment practice scores of my 11th graders depending on the time of day students take the test. And hypothesis 1, which is our claim, is that there is a difference in the writing assessment practice scores of my 11th graders depending on the time of day students take the test. Step 2 is to find the critical value from table K. The number of students we're working with is 6, and we're going to measure it at 0.05. So if you'll just turn to table K in the back of your book and then correspond to n equals 6 and 0.05, you will find that the critical value we're going to use for this problem is equal to 1. Step 3 is to compute the test value. Now step 3 is made up of multiple sub-steps. So for the first step, step 3A, is to make a table. So we're going to lay out all of our data here. In the far left column, you can see all of the students that we've tested. The next column, you can see that students' morning scores. And the next column, you can see that students' afternoon scores. Step 3B is to find the differences, which is morning minus afternoon, and place those values in the difference column. So as you can see, all of our students are listed. Then their morning scores minus their afternoon scores, and we have placed those scores in the difference column. Step 3C is to find the absolute value from lowest to highest and to place those rankings in the rank column. So first, just note that the absolute value of any number except 0 is the positive value of that number. So our values are negative 0.3, negative 0.6, negative 0.1, 0, negative 0.2, and negative 0.5. So the absolute value of those numbers is the positive value of the specific number. Step 3D is to rank each absolute value from lowest to highest and then place it in the rank column. So I have the values listed on the top row, and on the bottom row I've already ranked them from lowest to highest. Step 3E is to give each rank a positive or negative sign according to the sign in the difference column. So if you look in the column on the second from the right, you can see what the rank is. So I've listed the rank for each student. So what we're going to do in the signed rank column is take that rank and then look at the positive or negative sign in the difference column and apply that positive or negative sign in the difference column to the rank in the rank column and put them together in our signed rank column. Step 3F is to find the sum of the positive ranks and the sum of the negative ranks separately. So our sum of our positive rank, there was just one, and it was 1. So it is our positive rank sum is equal to positive 1. And then our negative rank sum, we had 5. So we have negative 4 plus negative 6 plus negative 2 plus negative 3 plus negative 5, which is equal to negative 20. So our negative rank sum is equal to negative 20. Step 3G is to select the smaller of the absolute values of the sums and use this absolute value as the test value for WS. So the smaller of the absolute values was negative 20, and we're going to take the absolute value of that, and it's going to be 20. So our test value is equal to 20. So now we have to make the decision. So what we're going to do, the Wilcoxon Signed-Rank Test says that we reject the null hypothesis if the test value is less than or equal to the critical value. So in this case, 20 is greater than 1. Hence, the decision is not to reject the null hypothesis. So when we summarize all our results, we're going to summarize that there is not enough evidence to support the claim that there is a difference in the writing assessment scores of my 11th grade students depending on the time of day. Congratulations, you just worked a problem using the Wilcoxon Signed-Rank Test. Again, my name is Jessica Watts, and working through the Wilcoxon Signed-Rank Test was part of our final group project for Dr. Lewis Glover's elementary statistics class for spring 2014. Thank you.
Hi, my name is Brittany Simmons, and today I'm going to talk about the Kruskal-Wallis test as a part of our final group project. Just to give you a little bit of basic information about the test before I do an example, it was named after the mathematicians William Kruskal and W. Allen Wallace. It is a one-way analysis of variance, sometimes referred to as the H test, and it is used when you're trying to compare 3 or more means. In this test, data values are grouped and ranked, and it is always a right-tailed test. Now I'm going to use a PowerPoint presentation to do a real-world scenario with you. Alright, as you can see, this is the formula that is used for the test. And to explain a little bit about the formula, R1, R2, R3 is going to be the sum of the ranks of each sample. N1, N2, N3, and so on is the size of each sample. And capital N is the number of data values overall used in the information. So here's my scenario. A guidance counselor recorded information to see if the total number of bullying incidents reported over 5 months in 3 elementary schools is the same. At a significance level of 0.05, is there enough evidence to reject the claim that the number of bullying incidents in the 3 elementary schools is the same? So you can see the information that was gathered here for 3 schools, Westside Elementary, Fairview, and Lakewood. And we're going to use the Kruskal-Wallis test to determine what would happen in this case. So the first step we would want to do is state the hypothesis and identify the claim. The null hypothesis would state that there is no difference in the number of bullying incidents in those 3 schools, and the alternative hypothesis states that there is a difference in the number of bullying incidences in those 3 schools. The next step is to find the critical value, and because we have 3 schools here, our degrees of freedom would be 3 minus 1, which is 2. And according to Table G found in the textbook, with 2 degrees of freedom at a significance level of 0.05, the critical value we would need to use to compute this information is 5.991. All right, step 3 is to determine the test value. This step is how the Kruskal-Wallis test is different from other types of tests. You would first want to arrange all of the data from least to greatest and rank each value. So we have all the data here from least to greatest, each school it coincides with, and then it's ranked from 1 to 15 because we have 15 values total. The next step is to find the sum of the ranks for each school, and I color-coded each school to help this stand out a little bit better. West Side, those ranks are 1, 6, 10, 12, and 13, so that sum is 42. Fairview is 2, 5, 7, 8, and 9, so that sum is 31. And Lakewood is 3, 4, 11, 14, and 15, and that sum is 47. These sums are going to be important to us when we get ready to use the formula. So our next step is taking the information that we have gathered and putting it into our formula. So I have the formula up here again for us, and all of the important information. Here are 3 sums that we just did on the previous slide. And you can see how this was strategically plugged in to the formula, and that our test value, once it is solved out, is 1.340. So now that we have the test value, the next step is to make the decision about the hypothesis. Since 1.340 is less than the critical value of 5.991, the decision is to not reject the null hypothesis. So in summary, there is not enough evidence to reject the claim that there is no difference in the number of bullying incidents in the 3 elementary schools. The differences are not significant at the significant level of 0.05. Thank you for listening, and I hope you enjoyed the presentation.